Watch this one to finally understand the motor effect and Fleming's left-hand rule. When a current carrying wire is placed into a magnetic field, it will experience a force. That is what the motor effect is. Remember from my other video on electromagnetism, if a wire has current flowing through it, that generates a magnetic field around the wire. So if you put that wire into a magnetic field, those fields interact. That's where the force and the motor effect comes from. The things that will affect the size of that force, coming from this equation here, F equals Bill, include the strength of your magnetic field, that's B, the size of your current, that's I, and the length of the wire that is in the magnetic field, that's L. The bigger those things, the bigger the force on the wire. For Fleming's left-hand rule, take your left hand and place your thumb, index finger and second finger at right angles from each other, just like this. Think F, B, I. F is the direction of the force on the wire. B stands for magnetic flux density, which literally just means north to south of the magnetic field. And I is the direction of the current. Remember, in any circuit, it will go from the positive to the negative side of your power supply. Generally, the questions give you B and I, make you line up those directions, and then whichever direction your thumb is pointing, that is the direction of the force on the wire, which you usually have to find. Don't overcomplicate it, it's as simple as that. Let's practice a couple exam questions. Here's our first question. Get your left-hand rule fingers ready, line up the direction of the magnetic field, and then the direction of the current. Your current is going up here, so if you've got to twist all the way around and think where your thumb is pointing, it was going into the page. So the direction of the force in this case, I would write into the page. Great, here's another example. In this one, we need to find the direction of the force on this section of the wire on this side, AB. Again, just get your left-hand rule ready and line up the direction of the magnetic field and the direction of the current. Remember, we're talking about that section AB. So the field is going from there to there, so that's where my index finger needs to point. And then the direction of the current is into the page. So my middle finger needs to point into the page. Look where my thumb's pointing, it's pointing down, so the direction of the force here is downwards. Last one, this is probably the hardest motor effect question you could get, and I hope this is going to be on there this year. A reasonably common question. This is a simple electric motor. We need to figure out exactly why it continually rotates. So really, we need to see the direction of the force on each side of that coil of wire in the middle. Get your left-hand rule ready, and as before, line up the direction of your magnetic field and the direction of the current. The direction of the magnetic field, your index finger, nice and easy, it's going to be pointing to the right from north to south. But for this one, they've given us a circuit. So for the direction of the current, we need to figure it out using that circuit. Notice the positive side of the battery is on this side, on the left, so it's going to go around the circuit this way, up the coil, back and around that way. So if I first focus on this top side of our coil, the left side, direction of the field is left to right, that's my index finger. Direction of the current is into the page. Look at my thumb, that means the direction of the force is pointing downwards. So on that far side of the coil, there's a downwards force. On the right side of the coil, our current would have looped and start to come back. So my index finger still needs to be pointing north to